Ladies and gentlemen, welcome to the Soin College of Business keynote event, Analytics Unleashed. Yay! I am Shu Schiller from the Department of Information Systems and Supply Chain Management. It is my great pleasure to introduce this exciting event. Today joining us are the audience sitting here. And I also want to mention that we're streaming live online to audience, including a group of high school students at Bellbrook in their AP class, and traveling business professionals in the nation. Thank you all for coming. Today, analytics is transforming business and education. From the smart meters in your house managing utility, to the sensors on aircrafts monitoring engines, from electronic medical records that can help reduce avoidable readmissions, to school learning systems that can help and predict degree completion. Analytics has become a powerful tool for insight discovery, so your business can uncover new possibilities with your data and do better evidence-based decision-making. The analytics market is growing at 10% a year through 2018. What does this mean?
The right is forward, I see.
I can tell you at least one thing: jobs. My dear students, listen to this. In higher education, analytics is one fast-growing field. If you come into college today and graduate in 4 years, there will be 9 million jobs in the US that require business analytics skills. You could be the next data scientist. You are in demand. People think they need you even if they don't know exactly what you will do for their business. It's about discovery, right? In a few minutes, you will learn how to unleash the power of analytics from Mr. Bruce Langos. But before that, let me introduce someone who has some exciting news to share with you. Ladies and gentlemen, please welcome the Dean of the Soin College of Business, Joanne Lee.
Thank you, Shu. So unlike Dr. Schiller, I really know very little about data analytics. But for the one thing that I know about it is, as the College of Business, we cannot ignore it. Long gone are the days that we teach what we think is right for the students, right? So as a Soin College of Business, we believe what really makes education relevant, and we need to stay relevant, is responsive to the market. So in a sea of business programs, we must think of something that we need to do it in a very unique, very special way. Now I want to say President David Hopkins is here with us. Let's give him a big hand first. Thank you, President, for your support of the business school. Now, but because he's here, that actually kind of reminds me to do a little plug for the business school. Dave is coming. The Data Analytic and Visualization Environment Lab is going to start probably, groundbreaking spring next year, and we project to be completed this project by end of summer next year. So with this particular lab, we'll be able to indulge ourselves to engage in a three-way learning model: students, faculty, and business. And students will be working alongside with faculty and business people to do real data analytics. And also, I want to tell you another thing, is the new analytics courses are coming. MIS 4300, the business analytics, will be offered in spring 2015. This is a perfect elective to start with understanding how to do business applications of analytics. Applied analytics will be co-taught by our IS department and computer science in the summer. So please take a bite of the technical analytics and get ready for data science. Now, I'm not here to steal the show from our keynote speaker, Mr. Bruce Langos. Bruce currently serves on our corporate advisory board. It is a super, super busy individual to track down. But the fact that he's coming here and take the time At first, I thought he was out of his mind, but he takes the time to come because he's really passionate about this topic. But I want to warn you, Bruce is very, very influential, and his passion is contagious. So, ladies and gentlemen, please give a Raiders welcome to the COO of Teradata, Mr. Bruce Langos.
Okay, let's see if we can get the technology to work right. So I'm happy to be here this afternoon. Hello to everyone. In case you don't know me, I've been around Wright State a little while, helping with Joanne with the School of Business, doing some things for Dr. Hopkins as well. So I'm glad to be here. And I think it's really important for the university to have a data analytics or a data scientist program, as I prefer to call it. And I'm going to give you some reasons why that's very important for us. And it's important for our region and important for the students. So I'm going to walk through some slides pretty quick as I do this, because there's some slides at the end I really want to leave you with that why this is critical for us. And I'm going to wander around a bit, so I'm not going to do the stage thing here. So let me first tell you a little bit about Teradata so you know who we are. We are a public company. Traded on the New York Stock Exchange. We have about 2,400 customers, which is, in the grand scheme of things, doesn't seem like a lot. But they're in roughly 70 countries. We're about a $3 billion company today. And we have won several awards that you see in here that I won't go through each one, but obviously a leader in data analytics, data warehousing, business intelligence, so forth. The important thing about it is we started much like I'd like to see a lot of students start in an entrepreneurial type program. Teradata was literally born out of a garage in California. And a couple of gentlemen got together and maxed credit cards and mortgages and so forth and had an idea about parallel databases and started the technology, which has yielded into a obviously very successful company. So I'd like to see a lot of that develop out of what happens out of Wright State as well, because there's great opportunity. We basically are in the following areas. So we do data warehouse technology. We have application-specific technology. We're in the software business. We're in the consulting business. We have partnerships with most key analytic technology providers. A big portion of our business, of course, is consulting on data warehousing and business intelligence and how customers should use our technology overall. This gives you a little bit of flavor. So if you think about the Fortune 500 companies, although most of our customers are in the Fortune 50 range, you can see where we have customers across the various industries. So we're well versed in what we do, and we have industry-specific people who target these technologies and these industries, and we've penetrated fairly well. So when we say we only have 2,400 customers, it's mostly the big customers that we have across the globe. All right, enough about us, because this is really about what's important for the university and for the students. So let me give you some industry trends. So how many of us think that the Internet of Everything has flattened the world, if you understand what that means, right? Which means we all have connectivity no matter what we do and what we touch. And you think about the sociability and mobility is more, better, faster, because all of us want everything now and when we want it, right, overall. Then think about sensor technology, and I'm going to go through some sensor capability that I know there's a lot done at the college on sensor technology, but really give you some case study examples of how sensors are being used and how important it is to do analytics with sensor data overall. Then we have what I call clouds and clouds in my coffee, which is cloud computing, right? Where I can have easier access anytime, anywhere via cloud computing at the same time. So we think cloud computing is great. And then, of course, what we call the Zeta flood, which is big, beautiful data. So I'm going to give you some differences between what big data actually means in the context of how we view it, because there's many definitions that you'll read about what big data is. So I'm going to cover that topic as well. But I'm going to spend an awful lot of time on the consumer so that you really get a feel for what's changing about data analytics. It's not about just capturing the data, analyzing the data, and then issuing reports. It's really about people who understand how to operationalize that data and make it into a competitive offering so that companies become more competitive. And I'm going to give you some real life examples of how that's happening. So think about this. So never before in the history of the planet have so many people on their own had the ability to have so much information at their fingertips at the same time, right? So when you think about it, data sharing throughout the value chain, meaning data is shared everywhere today, even amongst competition, in fact. And then consumer integration is now part of the value chain. So consumers really never were part of analytics that were going on. Companies did analytics to make a product more competitive, but they didn't include the consumer. Now today what's happening is consumers are forcing themselves into that analytic, and the companies are taking advantage of how you and I interact with all of our technologies, including televisions and so forth. And I'll cover that as we evolve. This is an interesting, Okay, this is an interesting chart, if you can see it from the back. I'm not sure that you can. But what I'd like you to walk away with it from is, think about the Internet of Things as a key enabler of making connections and accessing anything, anywhere. And a lot of you think we do that today, but we've just scratched the surface of it. Today, the number of network devices equals the world's population. So think about that. By 2015, shortly forth here, coming next year, the number of network devices is expected to double the world's population. So we'll have more devices amongst ourselves because of sensor technologies and other technologies that we're going to be using throughout our lifetime. By the time we reach 2015, it would take any of us 5 years to view all the video content on the IP network each second. That's how much traffic is going across the internet, right? Think about that. 5 years for us to view everything each second that's going across the internet on video. Now, then we have the rise of social networking. So I'm going to give you just some quick data. I'm going to go through these quick, and I'll let you read the slides. But what I call the consumer internet has really been a warm-up for the future of business, right? And the consumer internet is kind of a new acronym, right? Because consumers have taken control of the internet, and business is learning from consumers. It used to be that businesses would decide what they want to sell and what they want to offer, and they would push it to us as consumers. It's actually the other way around today. So when you think about Facebook, for example, has really socialized it's the socialization of everything when it comes to Facebook. So in 2004, there were only 1 million Facebook users. So far this year, what Facebook is reporting, there's over 900 million users already this year, right? So that's a short period of time of how rapidly that's grown. But the interesting thing about that is 60% of the people that are on Facebook today, 60% of those Facebook pages are from corporate America, because they've decided that Facebook is a medium in which consumers are interacting about their companies and their product and services and so forth. So it's become a way that now consumers drove business to be able to have to pay attention to what's being done and said about their companies on Facebook. So think about the rise of how social networking has now taken a medium on of itself, and we're all being forced to participate in it, including businesses. Now, then we have mobility on the move. So the purpose of this is to really point out to you that mobile e-commerce, the ability to take geospatial capabilities, which how many of you have a smartphone in your pocket or you're playing around with it while we're here? All right. So when you think about that, so now we can take geospatial capability. If you have your GPS turned on, there's a lot of people that know where you are sitting today that you may not know that you're sitting here today, all right? You opted into something that you really didn't know what you opted into, but someone is tracking what you're doing, I assure you, right, overall. So now, but it brings back to the point that 75% of the smartphones deployed in those volumes that you see in the chart, 75% of the utilization of a smartphone is still texting. which seems odd, right? Me it does, because I don't text a lot. And the next most popular activity is downloading applications. And then the next one after that is browsing. But texting is still the most popular way, but that's unstructured data, right? It's not, there's no form to it. It's unstructured. Right, so the lower right chart, which I know you can't read, really says that mobile will soon outpace personal computers becoming the primary design point for business. And that's why you see mobility taking a rapid change. Now, what people do differently and what's actually different today as a result of this? So far this year, there's been 40 million Apple iPad Airs sold by Apple. And the interesting thing about that is a third of those are being used for business intelligence today, right? Just in this year. I don't have data for what happened in prior years, but a third of the 40 million are being used in non-traditional ways. It's not just a consumption device. There's actual decisions being made from iPads and so forth. So that's an interesting technology capability, because that's also consumerization is now going all the way down to all the device connectivity that we have amongst ourselves. And then, of course, there's the getting into the future of Google Glass and so forth, which I'm not an advocate for, but that's where we're also headed. Another device mechanism, right, that's going to capture data. All right, let me give you an example of kind of what I'm talking to bring you to a point where you kind of understand what this actually leads to. So this is a consumer products company that is a customer of ours. And what they've done is they're using geospatial capability out of mobility devices, and their teams are able to track the longitude and latitude of products. They marry that data across the other data analytics that they have inside the business, and they know exactly down to the store location and the store ID, and deliver real-time information to their salespeople's iPads and iPhones, so that they know what consumer products by store ID, by inventory, by location are actually in those stores before they ever walked into them. And that helps them in a couple ways. How well is that store doing? Should they be placing products in that store? So let me give you an example. I always like to pick on Dr. Hopkins when I do this. So let's say that Dr. Hopkins bought his tie at Walmart, which I don't think he does, but let's say he bought his tie at Walmart. Now, the Walmart store over here in Beaver Creek, that may be a great tie to sell, right? And by the way, Walmart doesn't own anything on their shelves. It's all owned by the suppliers. The suppliers are the biggest users of their data warehouse. But when that tie goes across the scanner, the supplier is responsible for fulfillment, right? Not the store. The supplier is responsible for the fulfillment of that tie. But if Walmart sees that that tie is not selling well, they don't have to have anybody leave the store. Nobody has to do anything. They analytically, via the supplier, he or she, the manufacturer of the tie, distributor of the tie, moves that inventory to a store where it is selling. And no one touched anything. No one got involved. There's no human doing it, right? It's all done by data analytics. So all of that is being tracked. Every merchandise you see in a Walmart store is being tracked, no matter what. When it goes across that scanner, if it doesn't go across the scanner and it's not selling and inventory is staying flat and not moving, then the suppliers are electronically told what they need to do based on analytics of stores where that tie is selling very well. Think about all the humans that used to do that. Today they don't do it anymore. It's all done automatically. That's an example of how this will work. Now, this is probably a new thing for you, a new vocabulary word. We call it SPIME. So we've talked about what people can do with mobility. Now let's talk about SPIMEs. And SPIMEs are really sensor technology, objects that will always be aware of space and time. And sensor technology has become inexpensive and it's very small today, right? And sensors are really, really going to be critical going forward. So physical objects turn into spimes by adding sensors to them, making them aware of location. They know their history, and with communication skills. So think about that. Think about what's in that chip, right? All of the things I just said. So think about transportation, healthcare, security, energy, a variety of industries where sensor technology is really starting to take place, right? And it's going to surpass what we're doing in smartphones and iPads and the other things. And I'm going to give you a view of that in just a second. But think about, so remember what spimes are, right? It's a piece of technology, but it's any object in space and time wherever you're going to attach one of these two. This gives you a little bit example of sensor-aware capability. So there are 1 billion smart meters expected to be installed by 2020. All right, everybody know what a smart meter is? If you don't, raise your hand. Okay, everybody knows what a smart meter is. Sales of GPS devices are expected to reach 950 million worldwide by the end of 2014. And that's not including GPS devices that are on your phone, right, or your iPad. So the amount of information that can be captured from location and time, and those devices have the ability to communicate. So if you think about the billions of processors embedded in smartphones, cars, appliances, buildings, the environment, the kind of data that they're creating is huge amounts of data. Unbelievable amounts of data being created from that. So smart electric grids are measuring our home use of power if you have smart metering today. Their active people are tracking their heart rates, which I'm sure some of you may wear Fitbit bands or whatever. Hundreds of millions of users are uploading geotag data to Flickr every day, right? And Google Plus and so forth. We're all guilty of doing that sort of thing. All that data is being captured and stored. The question is, what do you do with all of it? And who has the ability to turn it into something useful is a different issue. This is just some examples of industries that are using sensor technology, but it's going to go even deeper than this. But the problem that we have today is the ability of people to make sense of the data and they know how to use it, right? That's the challenge. We are great now at gathering the analytics. This is a $100,000 Baccarat chip from Las Vegas. Not my $100,000 chip, by the way, but $100,000, right? Now, a lot of theft and a lot of misuse of that, you can imagine if you're a very slick person in Las Vegas. But look in the right-hand corner as I change the picture. That's a sensor. And through that sensor, that chip is tracked no matter where it's used on a table. If it walks out the door, it doesn't make any difference. They know exactly where that chip is at any time, so that there isn't any misuse and there isn't any fraud. But I wouldn't think that would be all that important, because if someone brought it in and it wasn't utilized in the casino, I would think it would be worthless. But to them, it's very, very important of the sensor technology and where the big dollar amounts are going. Now, think about aircraft engine maintenance. Let me give you an example of this. So if I told you that telematics, as we call it, is becoming very important. So see if you believe this. If we captured all the data from an electronic signal in an aircraft, dumping up to 1 terabyte of information per flight, for analytics when a plane descends below 10,000 feet, right, when telematics start to occur, the signals range from how many times the toilet is flushed on a plane, to the TV screens used in the individual seats, to the channels that are watched, and all the avionics data that's going on that plane. How many of you think that's actually occurring today? Not very many, but I can tell you it occurs on 2 major airlines today. And flushing the toilets is true. So it's because they want to be very reactionary to developing patterns, right? So if 40% of the plane did not opt in to use the screen that's on the back of the passenger seat, why not? what was the pattern of those usage? Did they play more games? Did they watch more of the satellite TV? Or they didn't like the movies, right? Whatever. All of that is being tracked. Do we need more toilets on a plane, right? So they're tracking everything under the sun to make sure that they can capture the consumer usage of the capability that's on the plane. Now, telematics is a term that we use because it's capturing a lot of information in manufacturing processes and cycle times and those sort of things that occur in the industry. But the most important thing is on telematics, and I don't know what I just did, okay, is the ability that the amount of data that's being flushed out of these sensors is enormous. Absolutely enormous. When that plane goes down to 10,000 feet, it's dumping a terabyte of information. I don't know if you all know about exabytes, terabytes, and petabytes, but let me try to give you an example of, if I told you that if you've been at a data center and you've seen disk arrays that fit in a cabinet in a data center, a terabyte of information could fill up to 8 floors of a building of data center capabilities, right? So it's large. It's a lot of information when you look at it. Now, so this brings us to what happens in the internet minute, right? I know you all can't see all this, but if you look at YouTube, Google, Twitter, Flickr, Amazon, Netflix, just you pick anything, right? And this is an important chart because it brings back even more about what I'm trying to get to show you where all the data influx is starting to come from. So let's talk about what happens in just 1 minute on the internet. How many emails are sent on the internet per minute? 204 million per minute. Some of you may know Amazon's revenue. So in a minute, how much does Amazon do in sales in a minute on the internet? Every minute of every day. $83,000 a minute. Right? And what they're capturing about you is even more important. 20 million photos are viewed and 3,000 are uploaded to Flickr every minute of every day by us, users and consumers. 6 million Facebook pages are viewed around the world every minute of every day. And they're capturing your pictures off of Facebook, and they're capturing what you're saying on Facebook. And corporate America has got 58% of the traffic, and they're watching what you're saying and what you're doing. And more than 61,000 hours of music are played on Pandora, while more than 1.3 million video clips are watched on YouTube every minute of every day by the world. Now, what's the importance of that? You, the consumer, have created the consumer internet. And you've dumped all this data out there in order for, you want to exchange it, you want it available to you immediately, you want access to it, you want to provide to it, but businesses want to learn from it, right? So businesses want to learn from it because they want to track patterns. And they want to put things in the cloud because the cloud makes it easy access for you, right? So when you signed up for, you did your iPhone, and if you upgraded to iOS 8, you automatically got, an iCloud feature with some storage, iCloud Drive, and you opt in. Whether you want to participate, you can opt out, but most people, frankly, they opt in. And the terms and conditions, how many of you read the terms and conditions? All right, so to my point. So you gave them access to what you're doing. You are participating in the consumer internet, and what they do with that is what? Patterns, behavior. So if I said, if I looked at Joanne's iPhone, and I went to the App Store, and on your App Store, it's got scrolling applications going across there, right? And if I looked at Dr. Hopkins' iPhone and looked at his App Store, they're not the same applications. Why is that? because they're only providing the ones to him that he's shown interest in, or a category he's showing interest in, which are different than Joanne's. So, and think about that, times every person that has an iPhone or an iPad, right? That's all going on in the background. Tons of data is being tracked. Basically, the purpose of this chart is pretty simple. We want, as consumers, immediate gratification, right? So I want it when I want it, and I want it now, is what we've evolved to. Besides being a throwaway society, the other thing we want is we want it, and I want it now. And we've evolved that way, right? And we've got technology to give it to us now. But what we're doing is we're giving businesses a lot of capability to learn what to do with that information. So the consumer internet has driven business change in analytics. So I don't know if Madonna really said that, but she did. All right, so I'm gonna deposit a theory here. How many CIOs are in the room? Any? All right, that's good or bad. So the next CIO is really the CMO, which is the Chief Marketing Officer. Because the way we've turned the consumer internet into a huge business opportunity, the CIO is driving infrastructure and technology, but the CMO is the one that has to deliver the capability from all the data that's being analyzed and looked at into a competitive advantage for their company. That's why CMOs are basically telling CIOs what to do in today's environment. We're seeing it more and more every day because you have to have competitiveness and you have to drive that analytics into a competitive advantage. Just to make a point, 45% of consumers today ask friends for advice before purchasing something, but only 18% rely on the retailer or manufacturer to ask them something, right? So we're likely to go to our friends. How many of us, when we go to Amazon or eBay, click on the 4 or 5-star reviews, right? All of us do, right, at some point. But how many of us call the manufacturer and ask a question? Well, for one thing, you can't get through when you call, but I think that's a whole different point. But I think it is important to tell you what's going on with disruption. So the disruption is, what do we do with all this information that is now unstructured, structured, and censored technology that is a place and time, right? And it's in movement. How do we capture all that? But more importantly, who analytically can do something about it? All right, so the point here is the consumer is now in the center of data management, all right? So we have big data, we have customer relationship management, analyzing and decision making, mobile applications, all this you're familiar with. But now the only thing that we've changed is the consumer is now sitting on top of the data management because you're the one providing the data, right? You're now providing the data. We're not just taking it from operational systems within a company. You're providing the data and driving the operational systems within a company. That's where it's actually coming from. So the world has changed from a business perspective of what's happening. I don't want to spend a lot of time here, but the purpose of this is just to let you know that the volume, what I'm trying to get across to you, the volume is exploding. And the volume is unstructured and not as structured as it used to be. So data analytics is harder because we're used to normally dealing with just structured data over a period of time. Now there's new technologies from what's called SQL technology, non-SQL with Hadoop and MapReduce and so forth that are making a huge difference in this unstructured data approach. But the purpose is we've got people-generated data, we've got machine-generated data, and then we have, in addition to that, we have the real-time data and historical data that we all want access to in parallel with all the other data that's going on. Okay, so what really is big data? And I think I just kind of touched on it a few minutes ago, but big data to us is, we've been in the big data business a long time, so it's really large volumes of data. That's how we look at it. That means big data to us, right? Large volumes of data. But then there's multi-structured data types where you have web logs and sensor networks and social media data and text where insights can be uncovered, but who has the skills to uncover a multi-structured environment? Very comprehensive and very hard to do. right? Very hard to do. And then we have semi-structured data that requires either a non-SQL analytic or MapReduce, as I just talked about, which makes it even more complex to try to deal with. Now, all three of these things, though, are flowing together. All that volume of data is being created across those categories. I'm not going to spend time on this, but this is just the industries that will benefit from big data, but essentially you can say that all of them will. All of the industries will benefit from having big data capability. All right, so now I want to get into why this is important to Wright State. Why all this volume of data, whether it's structured, unstructured, consumer, sensor, wherever it comes from, why it's so important. Mainly because mathematicians are suddenly very sexy, right, in the big data world. And becoming a data scientist, and I'm going to give you my definition or our definition of a data scientist, is really it's a new breed of analysts who know technology, which I know you can educate on here. They know data, but they may not know business. And the problem is with not knowing the business is, do they have the ability to know how to apply all three of those insights and build new models and new analytics to take advantage of all the types of data that I just talked about? And the answer to that is no, they do not, right? All right, so data is widely available. What is scarce is the ability to extract wisdom from them. And believe me, this is a challenge for us, but more importantly, it's a challenge for our customers. Very, very hard. Analytics is a competitive weapon. 58% of the businesses, organizations that use analytics have 2x substantially outperformed their peers, statistically proven, right? But the gap is widening. So those that have transformed analytical environments to those that not, we see them becoming less competitive and proven by their results. The importance of using it as a competitive weapon. The point here is, as I talk further, huge opportunity in the marketplace. Absolutely huge. All right? It's almost unlimited when you look at the type of analytics that are going to be needed to be done. So mobile, big data, cloud, the volume, the speed in which we want it is really going to have to change not only the way we operate, but it's going to have to change the way we teach about how to do this, because it's evolved so fast, but businesses are so hungry that we're not keeping up with that change because we're not creating enough graduates with this capability. There's not enough people on the planet to do it. All right, so this is kind of what I really wanted to get to. So data scientist, all right? It is the sexiest job in the 21st century. No doubt about it, all right? And enormous amounts of data, online behavior of Facebook users, they're going to look at tissue samples of cancer patients, they're going to do purchasing habits of grocery shoppers, which is already being done today, crime statistics of cities, and the data scientists are the magicians of the big data era. Tons of volume. Volume is big data, all right? Then they have to crunch data. They're going to have to utilize mathematical models. They're going to have to create narratives or visualizations to explain what they've created, and then suggest how to use the information to make decisions. The last two bullets on that are the most important. Are we teaching for that here? If you are, those of you that are here, do you feel like we're teaching for that here? Okay, no hands. To my point. Now, the right person in this field can design intricate models, algorithms, visualizations that can help companies distill insights from huge volumes of data. It's not just being a mathematician or a statistician. Very different. But, and there's a big but I put in there, which is also understanding the business challenge, creating valuable, actionable insights into the data, and communicating them to business. All right? So now let me kind of pick on something. So I spent a lot of time in Silicon Valley because we have several locations in California. And if I grabbed a Hadoop analyst off the street or a MapReduce analyst off the street who's in sandals and all that kind of stuff, and I said, okay, you are a whiz at creating the models, analyzing the data, looking at the patterns, the associate data relationships. Now, tell me what I can do with it. And that's when the conversation ends, right? So how do we put those three things together? Because data scientist is a hybrid computer science software engineer statistician. It's a long new thing, right? But they tend to be really curious people, thinkers who ask good questions, are okay dealing with structured and unstructured environments, but they have to try to find structure in them, which is a new role of finding structure within unstructured environments. And those who don't mind six-figure salaries like some recent graduates are getting, all right, because that is the case. So let me go to the next one. Shortage is severe in the US. 80% of new data scientist jobs created between 2012 and 2013 have not been filled. They don't exist. The people don't exist. And colleges and universities across the globe are running rampant to try to put curriculum and programs together to fill these jobs. Because literally, the $100,000 that I'm talking about of these people getting in those salaries, they are literally getting those. I don't know what I did to my button, but. So think about this. Universities can't turn out data scientists fast enough. In the US, we need to increase the number of graduates with skills handling large amounts of data by as much as 60% than what we're producing today. And there will be almost 500,000 jobs in the next 5 years and a shortage of 200,000 qualified data scientists, plus a need for another 1.5 million people who are executives and support staff who have the understanding of the data, right? Businesses turning it into competitive information. There's a war, literally, for this type of talent. Literally, there is. Requires discipline across the academic field. So courses in statistics, analytics, computer science and math, coupled with a specialty the student wants to analyze, i.e. like marine life, or they're interested in historical text data, whatever their interest may be. But most important, and this is the most important thing I can leave you with, is students must be able to communicate their findings visually, orally, and they need business know-how, perhaps to even develop new products. So I know the students are great analytically, technical skills, and they love that sort of stuff, but then when it's done, because now all the data is censored, unstructured data, structured data, associative data, developing patterns, capabilities, those are all good technical things to know how to create, but then I've got to know and turn that into something that's valuable. And that's the skill that's missing, right? That is the skill that's missing. To be successful, you need to have a broad range of skills that doesn't fit one department. So I've been encouraging Joanne, the dean, to get with computer science, to get with the marketing organization, all right? To get even with the healthcare organization that you have, the healthcare education here, and create a different kind of environment that you probably haven't done before, where we're going to turn those different disciplines into data scientist people. And there's a curriculum associated with that. And you choose a specialty that those students may want to participate in. But if you don't connect all the dots, then you're just walking out with someone who took computer science and may have some data analytics capabilities, right? But then you missed, how is data scientist, what does the data analytics mean in healthcare? How does that connect to data science? So if you don't connect those dots and bring curriculum together, we're never going to kind of solve the problem. So it goes across departments. Is it even possible to instill in a single person all the skills needed from statistics to predictive modeling to business strategy? And that's exactly what we're talking about. And the answer to that is yes, because there are colleges producing them. But more importantly, one thing I've learned from this is it requires those students also have very important internships, more than what they do today. Because I know you can teach them computer science, and you can teach them data sets, whether large or small data sets and analytics and so forth. But what you can't really teach them is the whole segment of business strategy. And that needs to be done inside a company. So those internships at companies become even more critical as they want this data scientist role. Because they're going to have to turn what they've learned and the predictive modeling they've done and the analytics they have the capability to produce. What does that mean to that business? Because that then becomes their value. That really becomes their value. It remains to be seen, but what employers want is someone who can do it all. And that's why the data scientist compensation has gone up so rapidly. It reminds me of mobile computing, frankly, where there's shortage of mobile computing, kids, I'll call them kids, who can develop on iOS and Android and so forth. And if you look at some of the resumes that we've received, they've jumped from job to job to job, and the salary's gone up just tremendously because they're in such big demand. This thing is 10 times worse than that because it's harder to teach these people, and it's harder to get them the business strategy that they need. But the data scientist role is going to be just tremendous opportunity for Wright State. I think you have all the skill capability if you can put the curriculum together to bring it more closely to an integrated, connected dot view of creating data scientists around different disciplines, and then participating with business to make sure that they get the business strategy piece. And I think it's just a great opportunity for the university to be able to do that as quickly as that can happen, because the demand is just off the chart, and it's going to be continued off the chart, because if you believe that, which I do believe, 80% of the need of the jobs from 2013, 2012 are unfulfilled today. So what do you have? You have people like the mobile computing. These guys are leaving one job, making $100,000, and they're staying less than a year in that job and going over and making $200,000. And then they jump to the next and the next year and making even more. And they're getting sign-on bonuses that are huge because there's no one standing behind them. There's no fulfillment, right? So you are the fulfillment arm. I know businesses are willing to participate with you in that, but I think the curriculum, and I know that's easier said than done because there's laws and rules and so by the state of Ohio that you got to do curriculum things and so forth. But if you can connect the dots to create data scientists around disciplines and bring your departments together to work on that collectively, it's different than just taking one course. It's several courses that just make me into this kind of data scientist role. So I would encourage you to go do that if possible, because the data is there. You, the consumer, have created it. We, the businesses, are going to take sheer advantage of it. The problem is we have to have people that tell us what it means, and that's the difficult part, right? Thank you.
Thank you so much, Bruce. We have time. We have about 10 minutes, and I would love to welcome questions. You would miss this opportunity and regret if you don't ask a question. All right, great.
It sounds to me like these are some skills you could start developing in high school. And I wondered if anyone is reaching out to the high schools to start developing more of the statistics and computer science skills.
The answer to that is yes, but I would also answer it unsuccessfully. So some of the businesses we've gotten together locally and tried to create our own curriculum, because we have a Teradata University and others have their own kind of education of the companies that were participating. And we did approach a couple of local public schools to try to do two things. Show high school kids what we're all about. So because what are their really interests? Are they interested in data analytics, or are they interested in something else, right? A doctor or whatever. So first thing is to let them know that we exist and jobs exist, and what the field is all about and what you get into and so forth. So we proposed a campus, if you will, of students who they would take courses as they normally would for high school, but we would also try to get them high school credit if they would then leave high school campus and come to work with us. So we would mentor them and shadow them through the process and turn them into what we wanted to make them into but get credit for doing it from the state, right? And that's a bigger challenge. We had full participation by public schools that wanted to do it, but it's a big hurdle to try to get through. That was our way of trying to circumvent the lack of resource to do it, and also getting kids an advantage of knowing what jobs are available, right, at the same time. So we tried.
I'm curious about the lack of inclusion of the social sciences and how people think about skills, like sociology and psychology in your list of they need to be able to do everything.
Yeah, haven't seen it. Just haven't seen the need. It's not something that showed us there's a gaping hole there. Just to be honest about it.
First of all, thank you for coming over and talking about data analytics. I think it's a wonderful domain which very few people know basically the definition of big data. So thank you so much. Really appreciate it.
My pleasure.
I specifically liked one of the comments that you made regarding visualization and finding the insights from the data, which in my world I call user experience, which I see as a big drawback that is there in data analytics. I want to get your professional thoughts on one thing, right? When I say this, data scientist does a lot of things, as you mentioned. If you really think about it, the data or the insights that comes off the data, I'm seeing it as more like a team sitting somewhere, looking at this big data, running the models, and getting answers to that. But if you look at specifically education domain, you don't really have that flexibility that you have in industries where you can have like 50 people or 100 people in a big department.
Right.
So I want to get your thoughts on what you think about empowering the users where they can make these decisions, but the big data is driven in a way so that people can look at data. When I say people, these are common people or ordinary people who do not really have any kind of education in running models or looking at models or running algorithms, but able to see the data and make decisions based on the data.
I think it's a possibility, and it's somewhat where we've been already. So we have users today who can sit in front of a screen, and the user interface is simple enough that they can do what we call ad hoc queries. So they can start querying certain things that they want to know, right? But what they don't have the ability to do because of the volume of unstructured data, whether you're using a SQL environment or non-SQL, whatever the case may be, they don't have the ability to extract that. It's got to be, data sets have to be created, whether large or small. It's got structured data unstructured data needs to be put into a structured environment. They don't have the capability to do that. You can give them reporting tools, executive dashboards, those sort of things. But that's why the data scientist is so important, because the data has changed so much, whether it's sensor or whatever, that they've got to put data sets together to make it meaningful to solve a particular problem and communicate what it really means. Then they also have to have the skill to be able to develop and understand the patterns between associative data. In other words, data that's in the peripheral that could impact that. People don't have the ability to do that, and I've never seen a tool that creates that either, because the data sets don't exist. So where you're describing is kind of what we do today, but we now know from the data that's being collected, it won't ever take us far enough. You're going to have particular people who are educated in doing it and skilled in doing it. I'm sorry. I'm sorry.
Yeah, you spoke a lot about the scale of the businesses that you work with, but there's an awful lot of our economy that's small business. To what extent is this analytics penetrating that space, and is there any future for small business in that context?
Well, I'd say yes and no. So small business, I think, will be able to take advantage of basic business intelligence via cloud offerings at some level. And the opportunity for small business is probably tremendous from what they don't know. The problem for small businesses, they can't afford it, is the biggest issue. So maybe as cloud becomes pervasive and the technology cost is driven down, that you'll have a cloud offering that a variety of small businesses could go into and utilize. But today it's cost prohibitive for the most part. That's why the adoption rate is not high. Even in mid-markets, I'll tell you, in mid-markets, the adoption rate is difficult because they can't afford it either.
Bruce, it's obvious that for the region itself, you are definitely a thought leader and a talent leader in this space, and we really do appreciate that. And the nature of my job in company attraction is that I get introduced to a lot of companies who are in this space, who want to come in and do business here in Dayton, Ohio. What you're doing here at Wright State is definitely a must. But at the same time, when we have companies that are showing interest here, we're the kind of like the middle people to introduce them to the industries and et cetera. But what is the right vetting model to make sure that we have the right type of expertise to hit certain types of requirements for the region itself, the ones who provide this type of capability? Because it's not easy to do. You got a good handle on it, but for us out there trying to make sense of this and increase the capacity here within the region itself, we need more thought leaders like yourself.
Well, I think the more you get business involved in what happens at Wright State, I think the better off you'll be. And I know that's somewhat easier said than done, but there's a lot of business involved with Wright State today. But I think Wright State is kind of a diamond in the rough, if you will, right? There's a lot of opportunity here for people. And I just don't think it's realized to a certain extent, and more businesses need to take advantage of the opportunity. I could see, for example, where I've made suggestions of, why don't we take the entrepreneurial center that's in Dayton and put it on the campus? Because I can't think of a better way to take startup businesses that are being funded, for example, by Third Frontier. So I sit on the commission for Third Frontier for the state of Ohio. And we've given away almost $2 billion. The governor wouldn't like me to say giving away, but we've provided $2 million, $2 billion. And that's startup capabilities, right? Now, so these are people who are starting a business. They've got a service or technology that they're passionate about. But what they don't have is an entrepreneur in residence expertise. So they need someone that helps them through what's the business model and the marketing model, and how are you going to make money at this thing? Well, you're teaching the same thing, right? So why not put the students with the startups for class credit, which I know is easier said than done, for class credit of helping those startups with their business model, their financial model, everything they need to get the business going, so that when they need more money after Third Frontier, they're out in their first round of funding, and you've helped them get there. And guess what? The students help them get there, and the students would learn so much by actually participating in a real company. I think that's one way to try to make that happen, right? And businesses need to be involved, and Entrepreneurial Center needs to be involved, and we need to utilize students for real life things that are going on within the community. And I can't encourage that any more than what I have. I keep encouraging her. Good. So I think if we get there, it helps everyone, right? It helps the business, helps the community, and helps the student. Hope that answered your question.
Last question. Yeah.
Bruce, I'm a student in the MIS program here, and one of the things that fellow students of mine are doing is helping to create the data analytics laboratory that Dr. Lee spoke about. What types of things would you envision that would be used for by the business community?
Well, the first thing I would do is, once you get it up and running, I'd make sure that someone makes their rounds to all the businesses in Dayton to let them know that it exists, right? And what its capabilities are. That'd be the first thing. Second thing is I would go after the base of mid-market companies that don't have the opportunity, skill sets, dollars, capital, et cetera, to take advantage of that. I'll give you a simple example. Montgomery County. So I've met with Montgomery County many times, just because I've worked with the commissioners and so forth on many different projects. to help them about, they want analytics, but they can't afford the kind of analytics we do, right? It's just too much money. But they dabble in it, and they have a product called Justice Web that they've created that is unique. But there's more analytics that they desire that would, one, it would cut our taxes because they would save money, and two, they know more about their county participants, right? And their suppliers and so forth. I would let them know that's available, let them design a couple of projects. What is it? What's the business requirement that they have? What's the need that they have? Let them explain that to your students that become part of the program, and let the students execute for the county. They'll learn so much in doing it, right? Both the good side of government and the bad side of government. But they'll learn so much of doing that it's an invaluable experience. So I would put it to use for those that really can't participate in the community without it. And maybe even charge for it, by the way.
All right, we're right about the time. I think Bruce really gave us lots of great ideas and almost a to-do list for every one of us. I really encourage you to take what you hear today and take some actions. How hard is it? Take some actions, starting from yourself. Be the change. Let's all do more analytics. Thank you so much, everyone, for coming.
Thank you all.
Thank you, Bruce.